Yeah, good morning, students. So let me share the file that I would like to complete today. Uh, anyway, uh, it's a great pleasure to see you all again for back to class. So today is the last class I would say for this unit. Okay. So today is the last class, and I have to go early. I have to complete class today early. For that, two important questions that I want to bring attention to you guys. It's a very important and so momentum energy heading. You can write it today. Class heading is first question 4 mark. There are two 4 marks questions here. Okay, one is the momentum energy relation. Uh, Right. So first you write it momentum energy. What is the momentum energy? Very, very important bit. I would say this question is repeated and not for actually for your semester exams. This question is important for all competitive exam. Every competitive exam there will be problem or there will be relation. So it's very important to keep in mind. Not for the, I mean, that is your life. I'm saying very, very important. Believe me, I mean, this is a very, very important equation to remember. This should be in your brain forever till your last day of your life. That is important. Okay. If you want to be continue in physics, this is very important to keep in your brain. So yes, momentum energy relation. So what is actually momentum? We all know that we already learned that momentum is the product of mass and velocity. We also know that energy, there could be kinetic energy, but E is equal to mc square is the one of the another energy equation according to the Einstein.
Still,
Okay.
sir.
And these two relation, what is the relation between these two? We know that P is equal to mv. We know that E is equal to mc square. And we have to obtain the relation between these two. But how do we get it? I mean, as you know that, you can see here, the energy, the total energy of the particle from the relativity theory. So we all know that when I say relativity concept, you should remember that E is equal to mc square, but here m is relative, right? M is not constant. M is also relative with respect to like m naughts by root of 1 minus v square by c square. So when I substitute this, which we got it yesterday, I mean, you all know that, right? So yesterday we have obtained the mass relation with respect to the special theory of relativity, which is called m equal to m naught root by 1 minus v square by c square. This is the relative mass. You should keep in mind, m is a relative. Like as we did x time position, time, mass, or relative concept. Okay, because we are talking about two frames. One is inertial frame, the other one is non-inertial frame. Or we are taking the one is the rest frame, the other one is moving with a uniform velocity. Okay, here E is equal to mc square. Okay, and m is you have to substitute here, m naught by root of 1 minus v square by c square. Don't write this one by students. I just mistakenly typed m naught c square by 1 minus v square by c square. And what is this? We know that P is equal to mv, where m is again you have to substitute this m naught v by root of 1 minus v square by c square. So now what I'm gonna do, I wanna multiply on both sides by c. I wanna multiply c on both sides for this above equations. So what are you gonna get it? P is equal to mv. So we got this one, and here I'm multiplying both sides by c. So it's going to be PC m naught vc by same. Okay. Then what else, sir? What we have to do here? So here simply what I'm doing here, you have to square. Let us say if I say 1, if I say this is 2, so what I have to do, square it, equation 1 square it minus equation 2. How do we get it? First, I'm going to square this. I'm going to clear first. So when I do square up this, what I'm going to get? I'm going to get it. See, here e square minus p square minus. So first you do square up this. When I do square, what I'm going to get? Tell me, guys. When I do the square, e square is equals to m naught square c power 4 by 1 minus v square by c square. Right? Then I'm gonna do p square c square. I'm squaring on this I'm squaring here. When I square it, what I'm gonna get it? M naught square v square c square by 1 minus v square by c square. Okay, then you have to subtract it. You can subtract this one. What are you gonna get it? E square minus p square is equals to, okay, what are you gonna get it? E square is this one, m naught square c power 4 by 1 minus v square by c square minus m naught square, okay, v square by c square by 1 minus v square by c square. So here LCM, this is LCM, right? You should write it. Okay, here what we are going to get. How do we get it, this equation? Uh, when I do that, when I square and subtract it, I should get it. Can I do the LCM of here? Hmm. So what I'm going to get, anyone can tell that? So LCM is same. So m naught square c power 4 minus m naught square v square c square by that. But why I'm not getting this? Is there any way that we can get it? Do you guys, I think it should come, right? What it should be same. I don't know why you're not getting. I should, uh-huh. Okay. So when I subtract it, this minus this, I should get, any suggestion, anyone from, give me 1 second. I'll check through with the textbook. Give me 1 second. Give me 1 second. Hold on, hold on. Hold on. I'll check. I think it should be. Hold on, hold on. I'll check this. It should be same. Right, right. I think we have to, whatever we did it is correct, but let me check it. Okay. So from here, let me go for the whiteboard. Whiteboard, where should I get it? So tell me guys, what is the E square value? E is equal to
M naught square.
M naught MC square, which is equal to M naught C square by root of 1 minus V square by C square. So equation number 1. What is the P? P is equal to M V M naught V by root of, is it clear? So then I have to multiply on both sides by C. So PC is equal to M naught VC by root of 1 minus V square by C square. This is same equation number 2. So square 1 and subtract it from, you can square both of them and subtract 1 minus 2. So when I do that, E square minus P square, you just need to square it better. When I do square, P square C square is equal to what I'm gonna get it? M naught square C power 4 by 1 minus V square by C square root will cancel, right? Minus M naught square V square C square by 1 minus V square by C square. Is it clear? Up to here, okay, right?
Okay, sir.
So I'm gonna see what I can do here. I think I have to take LCM is same. 1 minus V square by C square. So here M naught square, what is the common? Tell me. M naught square C square is common, right?
Yes, sir.
So here what is left here? Tell me.
C square
Yeah. C square minus V square,
minus
right?
V square.
Yes, sir.
Perfect. So now I can also take LCM in the denominator, right? C square minus, note down better. Don't, you can write down. So in the denominator also I'm writing C square minus V square by, tell me, by C square, right? Can I write it? Here, student.
Yes, sir.
Yes,
Okay,
sir.
sir.
Right.
I can write it like this, right? I'm denominator also I'm taking LCM. C square into 1 C square minus V square by C square. Okay?
Yes, sir.
So what I can do now, tell me, I can cancel this guy. Yeah?
Yes, sir.
So now what I can write? This C square will go and multiply in numerator, right?
4, sir.
And it is going to be M naught square C
C
power
power 4.
4. Yes, we are almost there. So finally, I am getting E square minus P square C square is equal to M naught square. See, this is a very important equation, beta. You have to remember it. Then I can also write it in a square bracket with a green color. E square is equal to P square C square plus M naught square C power 4. So you have to keep in this equation in your brain. I mean, you need to know how to get also. Is it clear for all of you?
Clear, sir.
Emana doubt unte adigan beta. It's very important. So first you have to write down this equation in relativity concept, because M is a relative. M should not be like M. It should be M naught by something. Yeah, this is a factor, gamma. So M is equal to M naught gamma. Gamma is a factor, that one. So P also M gamma V, because gamma is this factor. So when you write it these two and square it, E is equal to MC square. So square it and subtract it, you will get it this one. Take LCM and these two terms cancel, and this will be M naught square C power 4. So any doubts, please?
No doubt, sir.
Okay. Anyone from girls, can you give your response? Divya, Pooja, Kaveri.
No doubt, sir.
It's okay, right?
Yes, sir.
Very simple, Nana. You should remember this equation. Remember this equation. I mean, just square it and subtract it, and then LCM this right side. So you'll get it. So can I clear it? Can I delete it?
Okay, sir.
Take
Okay, sir.
screenshot and do it in the notebook. So అన్ని స్క్రీన్ షాట్లు తీసుకుంటే అంతే వదిలేయద్దు. ఇమ్మీడియట్ గా నోట్బుక్ రాసుకోవడం ప్రయత్నించండి. అది హెల్ప్ అవుతుంది. ఎందుకంటే మనం పెన్ పెట్టినప్పుడు ఇట్స్ కంప్లీట్లీ డిఫరెంట్. ఐ కెన్ సీ దట్ ఆల్సో. When I write it on the slide, I don't feel anything. But when I type on the board, definitely we can see some difficulties are there. Okay, you have to write it on a notebook so that it helps a lot. అర్థమవుతుంది బాగా. సో క్లియర్ చేస్తున్నాను. ఓకేనా?
Okay, sir.
Right. So this is the equation we got it. So this is clear. So this is a 4 marks question. This is also 4 marks. And one more equation, one more question. What is the 4 vector form? This is also 4 marks question. What is the, can you explain the 4 vector form in special theory of relativity? Explain the 4 vector. We know only 3 vectors, right? In general, we know only x, y, z. 3 vectors. Position means. But there is one more vector which is called time actually. So 4 vector form. So what is the 4 vector form in special theory of relativity? In addition to the 3 components of the space vector, we all know that space and time, right? Space is related to the x, y, z, and time is related to the t, right? So in addition to these space coordinate which are x, y, z, there is a time vector is also included. Okay, so we have to tell that 4 vector is simply in addition to the space vector x, y, z, there is a time vector also included, which we called actually 4 vector form. And the time component is regarded as a 4th component of the vector form. Time indicate actually 4th vector form actually. 4th vector, 4th component of the vector form. Okay, and the space coordinates corresponding to the, this point is also very important. Okay, last point carries 2 marks almost. The space coordinate correspond to the momentum, while time is associated with the energy. This is going to learn in quantum mechanics, play very important role. Whatever x, y, z which are related to the actually momentum related, right? mv, and v is related to the coordinates x, y, z. So the space coordinates are related to the momentum, whereas time is always related to the energy. What is energy? Tell me. Energy is equal to what? What is energy? Definitely related to the time. So it should be related to the time. So how do we get it? So in quantum mechanics, we're gonna explain this is a we're gonna write it d psi by dt. I mean, you don't know this, we're gonna learn in the final years. There is a Schrodinger equation, okay, in which you have a momentum and energy is there. Okay, so we'll learn that in later, but now you should remember simply space coordinates are related to the momentum, time is related to the energy. This point is important. The first point definition kind of, in addition to the 3 component of space vector, we have a time vector also included, which is actually 4 vector form, and the space coordinate related to momentum, while time is associated with the simply energy. Any doubts so far? So I think I mean, if you don't have any doubts, I can conclude for today class. It's I mean, let me I want to share some question papers also. Let's see, because we completed the chapter, right? So definitely we need to discuss what type of question